So there are some exact values that you are expected to have memorised. Now, whether that's using your exact value table, using your triangles, or another method that you've got, you are expected to know some of them. Now, there are also exact values that you're expected to be able to calculate based on this prior knowledge. So these types of questions would show up in a non-calculator paper. So if you were expected to find the exact value of tan 225, that's something that you're expected to be able to do without a calculator, but obviously you can check your answer on a calculator if you need to. So we are looking at tan. We're interested in the tan of this angle. So we're interested in the tan quadrant. So we're interested in this quadrant down here. Now, if we look at the value that we're given, we are looking for 225 degrees. Now, 225 degrees lies in this quadrant here. It lies between 180 and 270. And where that line lies, it is in the tan quadrant. That's the quadrant that we were interested in. So, tan 225 is going to be equivalent to tan, but of something else. Okay, so it stays as positive tan because in this quadrant tan's positive. Now, when you're trying to find your something else, it comes down to the calculation that you perform to help you find your next related angle. So if we were in this quadrant, we would do 180 plus something, and that 180 plus something would get us to 225. So again, we would do 180 plus something gives us 225. Now we know that to rearrange this to get x on its own, we would get 45 degrees. So that means that tan 225 is equivalent to tan of 45. Tan of 45 is an exact value that we know. Tan 45 is just 1. So tan 225 is equal to 1. So looking at this next example, we are looking at cos. Okay, so our cos quadrant is down here. So this is the quadrant that we're interested in. This is where cos is positive. Now, we're looking for 240 degrees this time. Now, 240 degrees, similar to the last time, it lies between 180 degrees and 270 degrees. So that actually lies in this quadrant here. Now, we're interested in this quadrant. This is where cos is positive. But we've actually got our line in this opposite quadrant over here. So what that tells us is that cos of 240 is actually equivalent to negative cos of something else. Now again, it's negative because we were interested in where cos was positive, but our line lies in the tan quadrant, and in the tan quadrant, cos is negative, so that's why it's a negative cos this time. Now, if we're looking at this quadrant over here where our line is, to find our number of degrees, we would do 180 plus x equals, in this case, 240. So if we rearrange that to get x on its own, x is equal to 60. So cos of 240 is equal to negative cos of 60. Cos of 60 we know is a half, but it's negative cos of 60, so our final answer is negative a half for this one. So cos 240 is negative a half. So as well as being able to do that in terms of degrees, you have to be able to now use your radian values as well. So the process for this is the exact same. The only thing that you have to be able to do is either convert your radians to degrees or know where your radians lie in your CAS diagram. So if this is 0 over here, it stays as 0. We know that 180 is just pi in terms of radians, and the two other values that you're expected to just know are 90, which is pi over 2, and remember I showed you how to calculate that in the last lesson, and 270 we should now be familiar with is 3 pi over 2. So again, we're starting with sine. So sine is this quadrant up here. So this is the quadrant that we're interested in. Now we have to figure out where 5 pi over 6 lies. So again, you could change that into degrees if you want, just to figure out the location of your line. However, the way that I would do it is, if you think about this pi over here, if I wanted to have a common denominator, that would be 6 pi over 6. Now 5 pi over 6 would lie to that side of pi. If we compare it to pi over 2, again looking for a common denominator, I need to times by 3. So that's going to be 3 pi over 6. And 5 pi over 6 would lie to that direction of it. So 5 pi over 6 lies in this quadrant here. It lies somewhere between 90 degrees and 180 degrees, somewhere between pi over 2 and pi. So because our line is in our circled quadrant, that means that we're still working with positive sign. So sine 5 pi over 6 is the equivalent to sine of something, and we need to figure this something out. So in this quadrant here, we would do 180 degrees, but remember if we're working in radians, that would be pi. We would take something away from it, and it would give us 5 pi over 6. So by the time you rearrange that and work your way through it, we're actually using pi over 6. So sine 5 pi over 6 is equivalent to sine pi over 6. So again, using your exact values in your radians, or by thinking about pi over 6 in terms of degrees, which would be 30 degrees, we know that sine pi over 6 is just equal to a half. So sine 5 pi over 6 is also equal to a half. For this final one, so again, we're working in radians. So remember, you've got 0 over here, and pi is 180 degrees. 90 is half of that, so pi over 2. And then 270 is 3 pi over 2. So for this one, we're looking at tan. So tan is this quadrant down here. And we're now looking at 2 pi over 3. So similar to that previous example, I'm going to get some common denominators here. So I'm going to use 3 as my common denominator. So pi would just be 3 pi over 3. 2 pi over 3 would lie in this direction. Now, for your common denominators this time, you are going to have to change this slightly because 3 and 2 are going to have to go up to 6. So this would be 3 pi over 6. The question, the part that we're looking for, would go up to 4 pi over 6. If we compare 4 pi over 6 with 3 pi over 6, it must lie in here as well. So our line is going to be in our sine quadrant, so our line is over here. So tan 2 pi over 3 is going to be equivalent to negative tan of something. Now remember, the reason that that's negative is because tan is down in this quadrant here, but the line that we're looking at isn't in that quadrant, it's up here. So in the sine quadrant, tan is negative, which is why it becomes a negative tan. Now we're trying to figure out what our related angle is. So in the sine quadrant, so in quadrant 2, we would do 180. So remember, 180 in terms of radians is pi minus something. And this time it gives us 2 pi over 3. So pi, take away something, gives us 2 pi over 3. So remember, pi would just be 3 pi over 3. Take away something gives you 2 pi over 3. We must have taken away pi over 3. So negative tan of pi over 3. So again, at this point, either know your radian exact values or think about pi divided by 3 must give us 60. Tan of 60 is root 3 over 3. So we've got negative root 3 over 3 as our final answer. So tan of 2 pi over 3 is negative root 3 over 3.